So this is the previous program, means which program which we discussed in earlier lecture. So this is program for stack using array. And here we know that you have to represent stack using two different way. One is using array and another one is using linked list. So for our particular experimental syllabus, we are having stack using array, stack using linked list, as well as queue using array and queue using linked list. So whenever we go for this particular program, here we declaring some functions like init. That init function is useful for initialization of stack. So initialization of stack means we have to write an initial condition for stack, which is stack is empty. So that condition only written in case of definition of this init function. Similarly, we go for push and pop function. It is like an insert and delete in case of any data structure. And similarly, we want to display the content of stack. So display function is useful. And stack having only one end open called as the top. So that should be declared as a variable here. And this is program for stack using array. So here we are declaring an array having name stack underscore ARR and whose size is equal to max. So value of max is equal to 5. And we know that we can put here 5 also. That is not problem. But here for this particular program, we are defining a macro as a name as a 5, as a name as a max and whose value equal to 5. So hash define is useful for defining a macro. And every program of this particular subject DS having a fixed structure means first we declare some variable and then here we call init function for initial condition of a stack, that is it is empty, and after that we have to create a menu. For creating menu we are using do while loop, and inside of that do while loop switch case statement is used. So by using these printf statement, we are creating menu like first option is push, second is pop, third one is display, and fourth one is quit. And user have to choose any of option in between these options. And suppose user want user choose option number 1, and then it goes to the case number 1. So in case number 1, we have to call push function. But before pushing data into stack, we have to check condition whether the stack is full or not. So that can be checked by using this condition, like if top equal to max minus 1, then stack is full. Else means top is not equal to max minus 1. Opposite condition as in case of if, and then you can go for calling push function here. And then in case number 2, we are calling pop function. So before popping, we will check condition like stack is empty or not. So it can be checked by using this particular line. If top equal to minus 1, and else means opposite condition of that, means top is not equal to minus 1. And in case 3, we have to go for calling display function. There is no need to go for any condition before calling display function. So we directly call display function in case number 3, and we will break the program. And then there is a definition of init function, definition of push function, pop function, and display function. So this is a program for a stack using array, and I already show you the output of this program also. But suppose we have to go for program for stack using queue using array. Similar program I want to modify for queue using array. So we know that queue having both end open, and one end is called as rear and another end is called as front. So whenever we compare this program with an queue using array, so there are certain changes like here we are defining max, that is again required because it is using array. Then we are going for init function, then insert function, delete function, and display function. We know that only push and pop, these terms are used in stack. So instead of push, we are using insert here, and instead of pop, we are using delete here, and display function is as it is. Then in case of queue, there are two variables, rear and front. So it can be declared here like int rear comma front. And here we have to declare an array also because this program is using array. So instead of stack underscore ARR, here the name is queue underscore ARR, and then size is equal to max. You can go for any name. For this program, it is q underscore arr, that is array name. Then we have to go for main program by void main, then again int op. And here one more difference is that here a variable data should be required for push function, but here in case of insert, no argument is required, means we only go for an argumentless function, so no need to go for declaring variable data here. And then we will create a menu by using this printf statement, like first option is insert, second one is delete, third one is display, and fourth one is quit. And in case number one, we are calling insert function. Case number two, we are calling delete function. Case number three, we are calling display function. Similar as in case of this program, in case number one, we are calling push function. In case number two, we are calling pop function, and in case number three, we are calling display function. Again, after that, there is the end of main program, and then again there is the definition of init function. So init function indicate initialization or initial condition for queue. We know that initial condition for stack is top equal to -1, but initial condition for queue, that condition is equal to rear equal to -1 and front equal to -1. We know that a queue having both end open, so instead of top equal to -1, this program contain definition like rear equal to -1 and then equal to -1. And then again we have to go for this second definition, like push in case of stack, but here insert in case of queue. So we want to insert new data in a queue, but before inserting, again there is we have to check one condition, like whether the queue is full or not. So it can be checked like if rear equal to max -1, then queue is full. Everyone carefully listen here. You can check condition in a case like this, or you can check a condition in function definition like this. Both way you can go for. Either you have to check condition in case, means before calling the function, or you can write also like this, means you have to go for definition of insert function, and before inserting we are checking condition like rear equal to max -1, then we will print like queue is full. Else means opposite condition of rear, means queue is not full, then you can go for insertion. So point is that whenever we are calling insert function, then program control goes to the definition of insert function. So definition of insert function is nothing but here. And in this particular program, we will checking condition like rear equal to max -1 before inserting. So if we know that in case of queue, the particular element is inserted from rear end. So here rear get incremented. You can write like this rear plus plus, and the element which is inserted at rear end. So you can write like this q underscore arr in bracket rear equal to x. So here x is data to be inserted in a queue. And before that, we have to make if front equal to -1, then we have to make front equal to 0. Then and then only we can insert in a queue. And similarly, there is a definition of delete function. So again, before deleting, we will check condition like whether the queue is empty or not. This condition can be checked in cases also, or it may be checked in the definition of delete function. So that condition which indicate queue is empty is front equal to -1 and front is greater than or equal to rear. These both condition indicate queue is empty. Else part means queue is not empty, then you can insert. And we know that in case we can delete, and we know that we can delete from the rear end in case of queue. So whenever we delete from front end, so front get incremented. Generally, whenever we perform any delete operation, that particular pointer for that particular space or location, it get decremented. But in case of queue, whenever we delete data from front end, the next particular item takes position of another front. So here front get incremented, instead of we have to write like this front minus minus. So here there is the front get incremented. And again, there is a definition of display function. So here before displaying, we will check whether the queue is empty or not. So that can be considered by using these two conditions. and else we have to print elements of q, and that can be front to rear, means I is equal to front and then I is greater than equal to rear, and you have to increment the value of I, and while incrementing you have to print whatever present in that array having name as a q underscore arr. So this program for queue using array, it is similar as in case of stack using array, but there are certain modifications like here instead of push we are writing insert, instead of pop we are writing delete, and then instead of declaring top variable we are declaring like there is a rear and front, and all other things are same. So whenever we see the output, we already discussed about output program like stack using array, but whenever there is a program like queue using array, so see here, this is the program which indicate queue using array. Here we are declaring function like init, insert, delete, and display. And one more thing I have to tell you, suppose I am using a definition or a name of delete function like small delete. Everyone carefully observe here. I am going for name of delete function like small delete, then this color is changing. Before this the color is what we can say that not a bold, but in case of whenever I'm writing like delete, then the color should be changing. So this indicate delete is a keyword in a C language. Delete is a keyword in a C language, so you cannot use any keyword as a function name. So instead of capital small delete, I'm using capital delete, means only D is capital and all other things are lowercase, then it should be okay. So all of you are getting small delete. This is a keyword in case of C language. So we cannot use that as a function name. So instead of that, we are making this capital first letter as a capital one and all other letters in similar manner or smaller case. Then we are declaring rear and front. Then we will create a menu here. And in case number one, either you have to write these conditions in cases or in case of function definition. Both way you can go. In that PDF, I am writing there in case of definition of function, but here I am writing in the cases. So before inserting any data in a queue, we have to check condition whether the queue is full or not. So that can be checked by using rear equal to max minus 1. And if condition satisfy, then it prints message like queue is full. Otherwise, data is inserted. And then there is a breaking of case number 1. In case number 2, we have to call delete function. But before deleting, we have to check whether the queue is empty or not. So that should be checked here. And case number 3, display. So there is no need to go for checking any condition before calling this display function. So we directly call by using its name and argument. There is no argument for display function, and then break the case. And after that, there is a end of switch, then end of do, and after that there is condition while OP is not equal to 4. We know that fourth option is quit one, and then there is the end of main program. So after the end of main program, there is the definition of init function, definition of insert function, definition of delete function, and similarly there is definition of display function. So all these definitions are present over here. And one more thing, if you want to go for saving this, then you have to save using .c extension. Everyone carefully listen here. This particular software, Dev C++, that can be useful for writing program for C as well as writing program for C++ also. So whenever you have to go for C program, then extension of that program means program name followed by .c. So .c is the extension for C program. And whenever we are going for C++ program, then extension is .cpp. For example, I am saving this. So again, file, and now this program is already saved. So I am going for save as. So whenever I am going for save as, so file name, you can go for any name. Suppose this program is named as 548, and everyone carefully listen here. There is a option like save as type. By default, it is C++ source file. By default, it is C++ source file, means .cpp. But our program is not C++ program. Our program is C program. So what I am doing, I am clicking here. Then there are number of options like all files, C source file, C++ source file, header file, and then a resource script. I have to save as a .c extension. So I am selecting like C source file. All of you are getting, so your program having name as a 548.c, and then whenever you are clicking on save, then the program is saved in a .c extension. So all of you are getting how to go for C program and C++ program. All of you are getting, yes or no? Am I audible to you, students? Am I audible to you? Yes or no?
Yes, sir.
Okay, so whenever everyone carefully listen here, this program is, or this software is useful for C as well as C++ program. So whenever you are going for C program, you have to save the program as a .c extension. And whenever the program is C++, then you have to save as a .c++ or .cpp. And if you save this program as a .cpp, then there is a error like this function return something, because in case of C++, the return type void is not allowed. In case of C++, every program having returns other than void means either it is integer, either it is character, or either it is a float type. So whenever there is a program of like C++, you are having error like void is not supported by C++, it is only supported by C. So there is error like return type or your program return something. So this is difference between C and C++ program. All the programs for this subject data structure, they are in C only. All of you are getting? So we have to see the output of this program, but before seeing the output, we have to compile it. So for compiling, I have to go to execute and then compile. And if there are zero errors and zero warnings like this, I'm going for running this program like execute and run. So you already know the output of program for stack using array, but this is program for queue using array. So I am going for option number 1. Then option number 1 is insert. So it is writing like insert data to be inserted in a queue. So it is 10. Suppose again I am going for option number 1, that is insert. Again, it is asking enter data to be inserted in a queue, suppose equal to 20. Anyone you can tell me how much data I can insert in this queue? How much data I can insert here? What is size of array here? We are specifying. What is size of array? Anyone unmute yourself and tell me what is size of array here? We are specifying. Anyone you can tell me what is size of array declared here in this program? What is value of max here? Anyone unmute yourself and tell me. So that value equal to 5. So we can say we can insert a maximum 5 elements in this particular queue. So here again, I'm asking for choice number 1. So it is showing like you can insert data. Suppose it is equal to 30. Again, I'm going for inserting data. So option number 1. Suppose it is equal to 40. Again, I'm going for insert option. Suppose it is equal to 50. So now a queue contain data like 10, 20, 30, 40, and 50. And again, if I want to insert a new data, whether the size is full, then it is displaying message like queue is equal to full. Means you cannot insert more than 5 element in this queue because the size of array is equal to 5. And again, I want to display the data present in queue. So I have to display like option for display is equal to 3. So my choice is equal to 3. Then it displays like queue element are 10, 20, 30, 40, 50. You have to observe here one thing, like whenever we are going for stack using program, a stack using array program, then output is displayed in the reverse order like 50, 40, 30, 20, and 10. But here in case of queue, it is displayed in a proper order like 10, 20, 30, 40, 50, because queue is working in which fashion? Anyone you can tell me queue is working in which fashion?
FIFO.
FIFO, that is first in first out. The data which first is equal to 10. So whenever I am going for second option, that is deleting, so the data first deleted is equal to 10. The data first inserting, that is again deleting. So it is working in FIFO fashion. Again, I'm going for second option, that is deleting. Then the data is 20. Again, I'm going for second option, data is 30. Again, second option, data is 40. Again, second option, data is 50. Now, nothing is present in case of Q. So again, whenever we go for second option, so it doesn't contain anything. So it prints message like Q is empty. So this is, in this way, you can go for inserting and deleting operation, as well as displaying content of a queue in case of this particular queue using array. And whenever I am going for fourth option, so fourth option is quit one. So whenever I am hitting enter, the program terminates. So this is program for queue using array. I hope you understand about program for queue using array. Now we will move further. We have one more program here which is related to application of stack. We know that there are different application of stack, like there is a evaluation of expression, then there is a expression conversion, then decimal to binary conversion, DFS traversal of a graph. All these are the applications of stack. So one of the application is evaluation of expression. So anyone, you can tell me which are types of expression? Which are types of expression? Anyone unmute yourself and tell me which are types of expression? Anyone unmute yourself and tell me which are types of expression? Okay, I will tell you. So there are three types of expression, like infix expression, prefix expression, and postfix expression. So there is a application of a stack, like you have to go for evaluation of this particular expression. So one of the application of stack is expression evaluation, and then you can evaluate a postfix expression using stack. So we have to now see the program for evaluation of postfix expression using stack. So there are certain rules for evaluation of postfix expression. Rule number one is, whenever we have to evaluate, we have to scan to the left to right, and whenever there is operand, we have to push on to stack. Whenever there is operator, pop to element from a stack, perform operation, and you have to push the result onto stack. And you have to repeat these step number 1 to 3 until all the operators and all the operands present in the expression get covered. And finally, you have to pop whatever present into the stack and print as a result. And we already discussed these particular examples, like there is example like a b star c plus d minus e plus, where a having certain values, and you have to go for answer, like final answer is 21 here. So this is a way or theoretical way in which you can solve or evaluate a postfix expression. But there is a program also. See here, this is the program for evaluation of postfix expression, and that is part of our experiment list also. So see here, this is evaluation of postfix expression. So here we are going for stdio.h, which is required for printf scanf. And again, we are using math function like addition, subtraction. We have to evaluate, means we contain different operators like addition, subtraction, division, multiplication. So we have to include this header file called as math.h. And then there is a ctype.h, another header file we are using here. And that is ctype.h, that is required for definition of function like is alpha and gets. Is alpha is alpha. This particular function is useful for checking whether the operator, or whether in expression you have encountered with operator or operand. We know that an expression is combination of operator and operand. Operator means plus, minus, division, multiplication, and operand means a b c d. So whether we have encountered with the operator or whether we encountered with the operand, so that can be decided by using this is alpha function. And we know that gets function is useful for taking input as a string. Then here we are going for a structure for stack, and here we are defining a macro having size like max equal to 50. And now in this structure we combine these two data types. So top is of integer type, and then we are declaring array having name as a data here and whose size equal to 50. So here we know that a structure is useful for combining a number of variables of same data type or different data type. And then again we are going for init function. So init is initialization, then it required an particular variable as argument. So stack star, so stack is the name of structure here, and star, whenever there is a star before or after this particular variable name, then it indicate a pointer. Then here we are going for pop function, push function, and evaluate function. We want to evaluate a postfix expression, so we are providing a character type of array having name as a postfix to this evaluate function. And then we will go for main program. Under main program, we're declaring this postfix array having size, and then we will print message like enter the postfix expression. That expression is stored in the memory using getS function. We know that for storing or for taking input from user in case of a string, we are using getS function, and then we will call this evaluate function. We declared evaluate function here, but here it is called in main program because we want to evaluate the postfix expression. So this is the end of main program. And after the end of main program, we have to go for definition of all these functions like init function, pop function, push function, and evaluate function. So everyone carefully listen here. This is this is definition of evaluate function. Here we are going for some variables like OP1, OP2 value whose initial value is equal to 0 and I. And then we are calling this init function. We know that whenever we want to go for performing any operation or stack, then we have to initialize it. By calling init function, we can initialize the stack. And here we are scanning the whole expression from left to right. The first rule is you have to scan the expression from left to right. So by using this for loop, we will scan the whole expression from left to right. If you want to scan the right to left, then you have to go for reverse for loop. But here we have to go to the left to right. So we are using this for loop. And here again, while scanning, whether we have to decide whether we have encountered with the operand or we encountered with the operator. So that can be decided by using this is alpha function. So we will provide this postfix expression as argument for this is alpha function. And if there is the operand, then rule says that you have to push the operand as it is in case of stack. So we will push, we will calling push function here, and then we will push the operand into stack. Else part means operand is not present, so operator is present. Else part means there is operator. So whenever operator is present, the rule says that you have to pop two element from the stack, and that element is stored in variable op2 and op1. So this indicates then pop two operand from stack and perform operation, and you have to push the result. So that particular operation may be plus, may be minus, may be multiplication, maybe division, maybe modular division, maybe raised to operation. So whatever operation we have to perform, we have to perform that operation, and then we have to push the result into stack. So here that suppose there is operator is +1, then plus operation is present, or it should be performed in that two particular uh, operands. So OP1 plus OP2, OP1 minus OP2, OP1 multiplication OP2, OP1 divided by OP2. So according to operator encountered, particular case is executed, and after that whatever value present in a particular stack, means final step is whatever value present in stack, that get popped and that is stored in variable VAL. We know that initially the value of VAL equal to 0, but at this point this value contain the expression value of that postfix expression, and then we will print message like final value is equal to VAL variable for that value. And then after the end of evaluate function, we will go for init function, then push function, and then we will go for pop function also. So these are definition of init function. Init means it is useful for initialization, and we know that initial condition for stack is empty. So in case of array, you are writing like top equal to -1 for stack is empty, but this is program for linked list. using linked list. So we are writing like s of top equal to -1. Similarly, we will go for push function. We will go for pop function. So whenever we will evaluate this program, means before executing, we have to compile this program. And if there are zero errors and zero warnings, I have to go for running this program. So whenever I am running this program, it shows me an expression like this, enter postfix expression. So we are having expression like A, B star C. So it is A, B star C, and then plus D, plus D, and then minus E plus. So it is minus E plus. So this is an expression A, B star C plus D minus E plus. And then again, it is asking values of each operand here. So value of A equal to 5, value of B equal to 4, value of C equal to 10, then value of D equal to 15, and finally value of E equal to 6. So I am solving this using theoretical manner, and I am getting output like this. So I am getting output like 21. So whenever I hit enter, I am getting output like final value of expression is equal to 21. So in this way, you can run this program on any postfix expression for evaluation. Once again, I am running this program for that second expression. So here second expression is this one. So it is 623, but we are not providing like 623. So instead of that, we are writing like in terms of AB. So it is ABC, then plus minus, then DEF, and after that plus plus, then multiplication, then G, and then raised to, and H, as well as plus. So I am writing this expression 623 plus minus 382 plus plus multiplication 2 raised to 3 plus in terms of A, B, C, D, E, F, G, H. And then I am writing each value. So A equal to 6 here, B equal to 2 here, C equal to 3 here, D equal to again 3 here, E equal to 8 here, then F equal to 2 here, F equal to 2 here, and finally I'm having G equal to 2, and finally H equal to 3. So in this way I'm getting answer like 172. So whenever I am hitting enter, I am getting output like final value of expression, which is equal to 172. So this is program for evaluation of a postfix expression, and that is using stack. This is an application of stack. So I hope you understood about this program, which is evaluation of postfix expression using stack. So in this way, here there is different functions are declared, and definition for that function is written like init function, pop function, push function, and finally there is evaluate function. So evaluate function, we are calling this is alpha function. The definition of is alpha function is written in C type.h. That header file we already inserted at the starting of program. And this is alpha function is useful for checking whether the operator is either operand or operand. Operator means you have encountered with either operator or operand. So whenever we encountered with the operand, we will push that operand as it is into stack. But whenever we encountered with the operator, then you have to pop two element from the stack, perform operation, and then finally you have to push result into stack. And at the end, whatever present into stack, you have to pop, and that is displayed using a variable VAL, that is value. So I hope you understand about this particular